All right, click on Volumes of Revolutions under Moodle. All right, so here are our formulas from yesterday. We have the disk method. If we have a horizontal axis of revolution, the equation would be v is equal to pi times the definite integral from a to b of r of x squared, the radius squared times dx. And this is based off the volume of a cylinder. And the integral gives you the infinite number of disks, which are cylinders. And there's your pi, there's your radius squared. The dx represents the height of the cylinder, which comes from the width of the rectangle that you're rotating around. Make sense? Now, when you have a horizontal axis of revolution, I want you to notice everything's in terms of x, because you're along the x-axis. You're along a horizontal axis, like the x-axis. Or it could be a horizontal line at y equals -1, or a horizontal line at y equals 8. But you're revolving it around something that's horizontal. So everything's along an x-axis or a horizontal axis. That's why everything's in terms of x. When we go around a vertical axis of revolution, like the y-axis, or like x equals 2 or x equals -2, everything's in terms of y. That's going to be the tricky one. The washer method would be, so we looked at a disk. We said, okay, if I had a this region again, let's say this dome-shaped thing, if I was to rotate it around the x-axis, that's clearly going to be spherical. You get like a lemon-shaped object or a football. And so if I rotate it around the x-axis, I get that sphere-shaped object, and that's a disk, because there's no gap with the region that you're rotating and the axis of revolution. See, the region that I'm actually rotating, the shaded region, the area that you're actually rotating about an axis, is actually completely flush or completely touches the axis of revolution. But if I was to rotate it around, say, y equals -2, that becomes that baseball with part of it punched out, or that watermelon with just, if you could take and cork it out. Okay? You get what I'm saying? All right, good. So if I was to rotate that around, you would have this, cylinder-shaped thing with part of it punched out through the middle. Because what you're going to do is you're going to be missing all of this. If I reflect it over, let me kind of reflect it over into 2 dimensions. See the other side of it. There's the other side of it. You're only seeing it in 3 dimensions, but you're seeing it from the top, kind of. And all this stuff in the middle, right here, is getting taken out. Okay? You're seeing it flat in 2 dimensions. All right? So if you're rotating this around, you kind of get it? It's a picture. It's hard. Yeah. So that's what we're after. That would be washer. And it's a washer because the axis of revolution doesn't touch the shaded region, or it doesn't touch it completely. It has to completely, the shaded region has to completely be lined up with your axis of revolution or flush with it. If it's not completely flush, then you know it's a washer. Does everybody see how we get washers? And what happens there in a washer is you have an outer radius and an inner radius. And what you do on your washer is you subtract the outer radius squared minus the inner radius squared. And what you're doing, right, really this is 2 integrals. If you kind of split it up, you'd see this as, it's from a to b of r of x squared dx. You're taking that disk and subtracting out the disk that we don't want. Okay? So that would be from a to b of little r of x squared dx. And so what you're doing is you're taking the whole disk, assuming it's all filled in.
Would you need the pi in front of the other one too? Or in front of both of them?
Yeah, it would be, the pi would be there. It's out front there as it gets distributed. And so what you do is you subtract out the whole disk. Okay? Because what we do is when you calculate the outer radius, you're finding all this. So that's going to end up being all this. So you're finding the whole thing. But then when you subtract out the inner radius, you subtract out the green part, and then you're just left with the black. Okay? It's hard to visualize, in 3 dimension. I know I have a hard time doing it. That's why when I showed you the sketch pad, where you can actually see the washers and the disc, it's helpful, because then you kind of get an idea of how it works. And if you want me to show you that again sometime, I certainly can. All right, so there's your 2 methods. Disk, washer, here, outer radius squared minus inner radius squared. Same thing for vertical axis of revolution when it's along a vertical axis like the y-axis, or x equals 2 or x equals -2. The only difference is everything's in terms of y. Now here's what I came up with for steps. Steps to find volumes of revolution. Step 1, sketch the area of the region that you're going to rotate. So first step, and some of you are like, well, that's not very necessary. It is actually very necessary. And a lot of times it's given. On the free response type questions, it will probably be given to you. On the multiple choice, you will have to sketch it yourself. Why do you need to sketch it? Because you need to figure out if it's a disk or a washer, okay? And then the other reason you need to sketch it is because you got to figure out what the radii are. You got to figure out what the radius is. And some people say, I don't need to know what the radius is. It's just a function. No, not necessarily. It's the function measured to the axis of revolution. Step 2, determine if it's a disk or a washer. It's a disk if the area of the region must be completely filled, it's a disk, the area of the region must be completely filled to axis of revolution. So it's a disk if the region is completely filled all the way to the axis of revolution, which basically means the whole region is flush. It is tangent to or touches the whole axis of revolution. There's no gap anywhere. Washer, make sure no cell phones, is the area of the region is not complete, which means there is a gap between the region and the axis of revolution. Still with me? Okay, so be focused, because they thought this a little bit. They thought, I get it, but you got to really think your way through it. Step 3, if disk, draw a vertical strip to represent the radius. And if washer, draw a vertical strip to represent the outer radius and another for the inner radius. Guys, if it's a disk, there's only one radius. If there's a washer, there's two radius. Two radii. There's an outer radius and an inner radius, because you got to subtract the inner part to form the donut-shaped object that you want. Because you got to subtract part out. Remember, this is key. Remember, you always measure the radii from the axis of revolution. And when you calculate the radius distance, you take top minus bottom if it's horizontal axis of revolution, and right minus left if it's vertical axis of revolution. That's really important. When I measure the radii, when I mark off that distance of that vertical strip or horizontal strip, depending on what kind of axis of revolution it is. It's a vertical strip if it's a horizontal axis of revolution. It'll be a horizontal strip if it's a vertical axis of revolution. If it's a vertical strip, and we're rotating it around like the x-axis or a horizontal axis, then you're going to go top minus bottom. And you measure from the axis of revolution. If it's a vertical axis of revolution, we're going to measure from that vertical axis, but it's going to be right minus left. Because you want to keep that distance, that radii distance, to be positive. So it's either right minus left, or it's top minus bottom. That's key. If you can do this, step 3 is probably the hardest part. If you get step 3, I'm confident you're going to get this. If you can't get step 3, you're going to have a hard time with it. Step 4, once you find the radii, I think it's simple then. Just plug it in the formula. Plug it in either the disk formula or the washer formula. And then step 5, use the integration process to calculate the volume or plug into the calculator. And the integration process is rewrite, simplify, integrate, FTC, fundamental thermocalculus. And it is a little bit of work. So we're going to do half and half today. So if you need to jump up and down real quick, get started, you can. Here we go. Examples. Find the volume of the solid generated by revolving the region about the x-axis. All right. What's the direction say to do? Revolve it around what?
X-axis.
So if you want to go ahead and partner up so you can kind of look at these together, but we're going to do the first one together, and then we're going to just work through as many as we can get through. And if we can get through 15 of these, it'd be great. Okay? Find the volume of the solid generated by revolving the region about the x-axis. So for the first 6 examples, we're going to revolve it around the x-axis. We'll do one with the calculator, one without the calculator, and then we're just going to set them up and move on. We're not even going to calculate. We're just going to see if we can do the setup step. All right, so here we go. Number 1, you got y equals negative x plus 1, y equals 0, x equals 0. What's step 1?
Sketch the area.
Sketch the area. So go ahead and do it real quick. And I would do it very big. Okay, I'd make it very big. I wouldn't make it small graph. So when you go up 1, I'd go up 1, but I'd make it, really go up 1. Okay, make that distance a lot larger than you normally would. So look how I did mine. I went up 1. Look how far up I went to go up 1. Okay, just want to make the graph big is all. Now, what's the slope of that line? Down 1, right 1. The reason you want to make it big, otherwise your area is going to be really itsy bitsy. Okay, draw that line. Now, just to go ahead and start out, how could you find these points of intersection if you were not certain that they were 1, even though I know they're 1? Like I know this is 0, 1, and I know this is 1, 0, but if you didn't know, how could you figure those out?
Set
All right, let's say, for example, this one. How would you figure that one out? Set negative x plus 1 equal to 0. Because you would be taking this equation and this equation. You'd be taking the x-axis, which is y equals 0. Right here is, I just want to show you this. I know this one's easy, but it's beneficial for other ones that are not that easy. So we got negative x plus 1. Tell me when my board comes back. Is it back? Hate it when the board comes. So we got negative x plus 1, which would be this line right here. Is it back yet? Still blinking? Not blinking? Good. So negative x plus 1. This right here is y equals 0, the x-axis, and this is x equals 0. So if I want to figure out where this point is, I'd have to take this graph and set them equal. And that's easy to solve, and I clearly can see that's going to be the point 1, 0. Because you'll solve this and get x equals 1. This one right here, you would actually put 0 in for x. Because you take x equals 0, and then this line, negative x plus 1, and put 0 in for x, and you'll get y equals 1. So that's going to be 0, 1. Everybody okay with that? Now, this one's easy to see because you graphed it and you knew it was up 1, right 1. So I don't think you had to do any algebra to do it. But for ones that are harder, you will have to do some algebra. All right, it's bounded by this curve, and this curve. So where's the region? You got to be able to find that area. It's bounded by this, and this. So where is it at? It's the triangular region. This is the region I'm rotating. Now what did the directions say to rotate it around?
X.
The x-axis. What is that going to form when you rotate it around the x-axis?
Like a round.
It's a cone. It's a cone. It looks like a Hershey's Kiss.
A round triangle is a cone.
It's pretty close to being what you would call a Hershey Kiss. Okay?
Not quite the cone.
Yeah, it doesn't have the concave up on the way at the top of the peak, but just a flat Hershey's Kiss, I guess.
Yeah, no.
Or think of it as a pile if you were to take sand in your hand.
Oh.
Form a pile, you form a conical pile of sand, right? Same thing. So if you rotate this around, you're going to get a pitcher's mound kind of up on its, tilted up on its side that has a pointy top. You know, it's real conical shape. So anyways, rotate this around the x-axis. Now here's my question. Your axis of revolution is the x-axis. So let's represent that vertical strip and I'll be able to figure out if it's a disc or a washer. Right here, from the axis of revolution to the furthest to the function, is my region completely flush with what I'm revolving it around?
Yeah.
So definitely a disc. Alright, so what I got to do is I need to represent this radius distance. So let's find that radius distance, that red distance there. That red distance is going to be, what did I say to do? It's either top minus bottom or right minus left.
Top.
In this case, it's top minus bottom. So what's the top function? Negative x plus 1. Now some of you don't think this is necessary, but let's just practice it because it will be necessary eventually. Minus the bottom function. What is the bottom function? 0. Now I know it's not a big deal here, but later it will be. It's not always going to be 0. We might revolve it around y equals negative 1. So we're going to end up with negative x plus 1 when you simplify for the radius. Guys, you're done with step 3. That really is the key to the problem. If you can find the radius, you've done step 1, you've determined it's a disk, now you found your vertical strip and you found your radius distance, now you go to step 4, plug it into the formula. We only got one disk, so it's going to be the volume. What do you put out front?
Pi.
Pi. Times a definite integral from what?
0 to 1.
It's along the x-axis because we're revolving it around the x-axis. So it's going to be from 0 to 1 of what?
X plus 1 squared.
Now the biggest thing that people forget to do here is square it. And then don't forget your dx. There's your formula. That's your setup. You get all kinds of points for that. Okay? Now, let's do this one by hand because I think it's easy enough. How do I go about doing this by hand?
You have to square the inside.
We need to square the inside first. The integration process. You simplify. You rewrite first. So if I square the inside, what are you going to get?
X squared.
X squared
Minus 2x.
minus 2x
Plus 1.
plus 1 dx. We got that by taking negative x plus 1 times negative x plus 1. Just did it in our head. All right, when you integrate this now, it's this simple power rule. What are you going to get?
1/3 x cubed.
1/3 x cubed
minus 2x squared.
plus x evaluated from 0 to 1. Now the pi just leave out front. We can deal with the pi later. Plug the 1 in. That's going to give me 1/3 times 1 cubed, which is just 1/3. Minus 1 plus 1, that's my f of b. We're doing FTC now, fundamental theorem of calculus. Minus f of a. Plug the 0 in now. What are you going to get when you plug 0 in? 0 though. So you're going to, what happens to 1s? 1s cancel. Leave your answer in terms of pi. You don't have to actually multiply by the pi, so it'd be pi over 3. What's the units for volume?
Cubed.
Units cubed. And if you don't know why it's units cubed, here's why. Some people are like, how did it end up being units cubed? Because look at this. This is radius squared. Units for radius is probably like, radius would be units. Radius squared would be units squared. And then you multiply by the height of the cylinder, which is really the width of that rectangle. That's another unit. So you got units squared times units. That's where you get the units cubed. All right, that's one without the calculator. Let's do example 2. Right now, on your own, do example 2. I'm going to go ahead and start sketching the region. Let's see if you can get ahead of me a little bit. Example 2. Same thing. Want to revolve it around the x-axis. Want to rotate it around the x-axis. See if you can draw the region. And then see if you can figure out if it's a disc or a washer. I'm going to scroll up a bit. I'm just getting annoyed. You can look at your steps, can't you? Step 1, sketch the region. Step 2, figure out if it's a disc or washer. Then draw your vertical strip or horizontal strip based on the axis of revolution. Since we're rotating around the x-axis, it's going to be all vertical strips. All right, what's 4 minus x squared? Upside down parabola shifted what? Up 4. And then you've got the y equals 0 is the x-axis. X equals 0 is the y-axis. So where is it? Actually, I don't need the x equals 0 in here. Take the x equals 0 out. Take the x equals 0 out. Sorry. Take the x equals 0 out. Now, can you see the shaded region? Because otherwise, I really didn't specify which part, the left or the right part. Where's the shaded region? It's that baseball mound looking shape, right? So it's all this. If you're using this, and you're using this, then the shaded region is all of this. Now, what are you going to get when you rotate this around the x-axis?
Could you just find half of it and double it?
You could. You could find half and double it. All right, now, how are we going to find the limits of integration? How do you find these points here? Because we're going to need them. You take the graph of 4 minus x squared and you set it equal to 0. Let's do that real quick because we're going to need it. So we're going to need 4 minus x squared set equal to 0. All right, let's solve that. You're going to have x squared equals 4 if I add the x squared to both sides, right? Take square to both sides. What do you get? Plus or minus 2. So we've got, it's going to end up being, this is negative 2, 0. This is 2, 0. Okay? So now we got everything. Now, let's answer the question. Is it a disc or washer?
Yes.
Yes, because the shaded region completely touches what you're rotating it around. Remember, we're rotating it around the x-axis. The shaded region touches the whole x-axis. There's no gap anywhere. It's completely filled in to the axis of revolution. Here's my radius. It's always measured from the axis of revolution to the function. So there's my radius in blue. So how would I calculate that radius? What did I say? Top minus bottom. What's the top function? What's the bottom function? That's nice. So it's just going to end up being 4 minus x squared. So somebody tell me, what would the definite integral be? We got a radius. We're done.
Pi times.
Pi. Always your pi first. Times.
Negative 2 to 2.
Now, I liked what Griffin said, though. We could have done from 0 to 2 and just do what? Double it. It is symmetric, right?
Yeah.
Well, we'll just go from negative 2 to 2.
Oh, 4 minus x squared.
Now remember, it's radius squared, so 4 minus x squared dx. Now let's practice with the calculator. Go ahead and type it in on the calculator. Like I said, you know what my former student tweeted on Twitter.
Want to find me on Twitter?
All right, let's go quick. Let's see how quickly you can do this with the calculator. You should be doing this. First thing you should be doing is, well, actually, I just do this straight from the home screen. I wouldn't even go to y equals at all. I don't use the bars in this situation. I just type it in on the home screen. So what do you got to type first before you do anything? The pi. If you want to put it, you got to go from the home screen, not y equals. This has got to be on the home screen. See, this is why we practice calculator.
107.2330292. Wait, what'd you get? I got 107.2330292. No, that's right. 107.1786.
That's probably this is the way you're doing it. The hard way.
Type in pi or you put the word?
What I do is go to the home screen.
Yeah, type in pi.
What'd you get, Mark?
Second mode.
107.233.
Type in
Nailed
pi.
it!
Type in
Pi.
pi. You get our-
You got it wrong?
No.
Trust me.
Math
You don't trust me?
9.
I
You gotta
trust
know
you.
where that's at.
You got it wrong.
Yeah.
Math
Type
8
in
is
three.
red. Math 9 is everything.
Calculus is.
All right, what did you get? What'd you get?
107.2330292.
What? I
107.23392.
can't understand a word you're saying.
107.233.
107.233 units
Units cubed.
cubed. There it is. And if you multiply by the pi, if you didn't get 107 point something, it's because you forgot to multiply by the pi. Okay?
If you use 3.14 on the exam, you're gonna get it wrong. Right?
Right? I got 107 point something.
You would have to round if your answer within like. Depends on how close they put them on the exam.
Or if it's free response, I'd probably go exact.
Why would I just go with pi instead of
Then what if multiple choice if they
I think
have
I'll just go with it.
1.723, 1.733, 1.743, and 1.7.
Whichever one I feel is right, it'll be right.
Or you could do this dialed in.
Maybe I don't have half the color to do on that head.
Oh, yeah, you know, do definitely really square it.
Good one.
Give me one. Give me an equation and
Yeah. Something like that.
All right, do we got it? All right, next one, number 4. Here we go, number 4.
Math is fun.
Me number 3.
3. Do we do 3 yet? All right, let's do that one fast. See how quickly you can set that one up. Set that out. I'm going to start sketching, and then all we're going to do is set up on this one, and we'll practice the calculator again. We're just going to keep practicing the calculator because you guys need it.
Wow. I don't really see how you could say that. Like,
You just need it. Trust me. Now this one's different.
So if they don't give you y, is it just 0?
Well, now you got your graphs. You got square root of x. What else you got for boundaries here?
1 to 4.
Oh, I'm missing a boundary.
Yeah, that's what I do. Y don't you
it's pi times z.
right?
You're missing y equals 0.
Thank you.
Oh. I just assumed that. I'm gonna call.
Isn't that still not?
You're gonna be looking at a Jello thing. What are they called?
Can we do it on the calculator?
Gelatin cake.
Can we do it on the calculator? Can we do it on the
Oh,
calculator?
you're gonna be looking at a gelatin cake here.
Can we do it on the calculator?
Yes. Said that already.
No, you didn't.
Yes I did.
Nah, Jack, did you hear him? I heard him. I cannot confirm or deny.
Who heard me?
I heard him.
Thank you.
Not me, sir.
23.5619449. That is the exact answer. Oh yeah?
Oh yeah.
We'll go stop it. Can't stop. So
You're looking at
if
pi.
I get this right, you won't
Man.
lose 3.14. I'm gonna use it and get a better answer than you did. That's laughable.
Okay, so
Wait,
it's I'm gonna just draw. You got x equals 1 to 4. Now listen, when you get these points, I want to explain something here. And I've got y equals 0. Sorry, I've forgotten that one there. So we got y equals 0, we got the square root of x, we got x equals 1, and we got x equals 4. Those are vertical lines, and x equals 1 and x equals 4. So here's the region that we get. Disk or washer?
Disc.
Because remember, we're rotating it.
Gelatin cake.
We're rotating it around the x-axis. Rotating around the x-axis. So it's definitely a disc. Okay? And might be beneficial to figure out what these points are. I don't know if it is, but what point would this be? 1 what? 1 what?
1, 1.
Yeah, because the square root of 1's 1. What would this point be up here?
2.
I don't know if you need them, but later on you might. Now, when you rotate this around, it's kind of like a baseball mound with the top part kind of shaved off.
Gelatin cake.
Yeah, very good. That's true. So what we're going to get, who wants to give me, what's the radius? Radius is measured from the axis of revolution to the function. So what would the radius
Top
be
minus
here?
bottom.
Top minus bottom, so square root of x
Square root of
minus 0, which is just going to be what?
Square root of
Square root of x. So, the volume, guys,
Pi
quiet,
times
please.
the definition
Pi
goes
times
from
the definition.
1 to
1
4.
4.
Shh, keep it down just a little. 0 to 1
No, 1 to
No,
4.
1 to 4.
1 to 4.
Of square root of x squared dx.
Now this one would actually be a very easy one to do by hand.
Could you just
Okay.
call that x?
Yeah, you could just call it because when you, guys, no, I'm talking now. Square root of x squared is x. Yeah, you could just call that x. Okay? Now, on my setup on free response, I probably wouldn't. If you're doing multiple choice, they ain't gonna see it anyways. So it'd be v equals pi, because you want to demonstrate you know the formula. 1 to 4 of x dx is the same thing, yes? And then you would integrate and get 1/2 x squared. This would be really easy to do by hand. You get pi, you get 1/2 x squared. Let me just do it by hand and see if I can get it. 1 to 4, plug in 4, you're going to get 16, which is going to be 8. So we're going to have pi times 8 minus, plug in 1, you're going to get 1/2. 8 minus 1/2 is going to be 16/2 minus 1/2. So you're going to have 15 pi over 2, which I don't know what it is as a decimal. What'd you guys get?
15 pi.
23.561.
And he nailed it.
15 pi over 2, the same thing?
Yep.
What is it as a decimal?
23.562.
Okay, good. All right, still okay. Next one, 4.
That's what it looks like.
Next one, number 4. Yeah, that's exactly what it looks like, but no hole in it.
We should make it.
Okay, number 4. You ready?
Gelatin cake.
Take out,
Go and kick it.
take out the x equals 0 on this one again.
Oh.
Actually, let me just draw this for you, and it's the same thing. We can just do this one real quick. I don't want to spend a lot of time on this one. What is this? It's the dome. Very good.
Wow.
The dome.
Nailed it.
What's the radius of the dome? Come on, it's a common graph. It's 2. You do the square root of 4. So you go up 2, left 2, it's a semicircle. Right 2, it's just this. And then you bound it by the x-axis. So you're just looking at this. We're not going to do another one of these. It just ends up being. But it would be volume. Listen. The volume. The radius would just be top minus bottom from here to here, which is just going to end up being this. And the integral would be from -2 to 2. So it's going to, yeah, it's not going to be anything special.
Yeah.
So we can move on. We don't need to do that one. I do want to do number 5, though.
Oh.
Number 5 is really interesting. Okay?
We're gonna have some.
Whoa.
We're gonna have some donuts.
No, now we're doing
Sorry. I don't lose that. Okay, number 5. Take a look at it. I'm going to zoom in a little bit on it, if I can. All right, there we go. Number 5. Y equals x squared, y equals x cubed. We're still rotating around the x-axis. You ready? This is a little tricky to think about as a graph. The graphs are easy to draw. Watch this. Shh. The graphs are really easy to draw. Okay, so we're going to have x squared looks like this. Now x cubed, now here's where you got to be careful. X squared and x cubed both start at 0. Does everybody agree?
Yeah.
Okay, but here's the deal. X cubed grows faster. This one grows faster than that one.
But they're the same at 1.
They're the same at 1. It doesn't grow faster until after 1. So let's just imagine this is 1, and this is 1, and there's a point. There's x squared. Hold on. I gotta take this. Hello? Yes, this is Jeff.
This is Carl.
Hey, how are you? Good. Yes.
Where's calling time?
With it. She's applying.
We want you to
Yep.
go to Oregon.
Okay. Would it be okay? Would it be okay if I call you?
See ya, AP.
Could I call you back in like 30 minutes? I'm in class right now. Okay, can I get a number? Okay. Okay. Okay, I'll call you back. Yep, bye. Okay, so this is what we got. X squared, x cubed. Now, here's why x cubed is below x squared from 0 to 1. They do cross at 0, 0, they cross at 1, 1. And here's how I knew that. If you didn't know, this one would have probably been drawn for you. But x, actually it wouldn't. Maybe it wouldn't, I don't know. You need to know this though. Okay, just have a good idea, a good reasoning of why this is. If I set these equal to each other and I solve for, or set it equal to 0, I'm going to get x cubed minus x squared equals 0. Factor out an x squared, we end up with x minus 1. And so we end up with x equals 0, double root, which doesn't matter right now because we're not doing a sign analysis. So 0 and 1, they cross that. Everybody agree?
Yes.
And they both hit the point 0, 0. If I plug 0 in, they both get 0, right?
Yeah.
Plug in 1, they both get 1. But they're not the same function. They grow at different rates. X cubed grows a lot faster than x squared, except in one place. Before 1, where there's fractions. From 0 to 1, x cubed grows much slower because when you cube a fraction, it actually gets smaller. Think about it. If you go 1/2 squared and you go 1/2 to the cubed, 1/2 squared is 1/4, 1/2 cubed is 1/8. So from 0 to 1, x cubed is actually below x squared. It's not growing as fast. It's not till after 1 that x cubed grows faster. Does that make sense?
Yeah.
So that's what we get for the shaded region. Now, x cubed over here goes over in this direction. So we know the only place where we have a shaded region where it's enclosed, the enclosed region then is right here. It's this fingernail clipping.
It's like a banana.
Yeah, banana. Now, I tried to visualize, try and think, really stretch your brain a little bit here. If you rotate that banana-shaped object or hammock, and you rotate it around the x-axis, remember, we're still rotating around the x-axis, what are you going to form?
Concave up cone.
Not really.
But a big part of it cut out of the
Like
middle.
like
It's almost
this.
like a flower. Okay? It's almost like a
It's like
pretty
a
tulip
pointy bowl.
that comes out, you know? A tulip.
Or a bowl
Or it
upside down.
extends
like
from the
this,
middle, the
pointy
petal,
ends.
like the
It's
middle of
like
the flower,
a pencil.
and the petals come out, and it's circular.
It's like a pointy bowl.
It's like a concave.
Yeah, kind of.
It's like
Or imagine, you know the penny race
It's like
when
a
you go to the
megaphone.
mall and you throw the penny in,
Yeah,
the
it's
penny's
like
in
a
out.
It's like a megaphone.
It's like the siren.
It's like a
Yeah,
megaphone.
that
Concave
works
up
too.
megaphone.
Really hard to see if you rotate this around three-dimensionally. It's a three-dimensional. It's kind of diving into this center point all around in a circle, kind of funneling in into this middle portion. Okay? All that middle stuff's cut out. Now, if I rotate around the x-axis, now here's the part that students have a hard time with. It touches it, part of it. Actually, just touches it 0 because it's not right. But there's this big gap. We got to subtract all this junk out. So this is clearly a washer. Because from here to here, we don't completely touch the axis of revolution. Here's our axis of revolution. Look at all this gap right here. So it's a washer. So there's 2 radii now for the first time today. 2 radii. There's an outer radius and an inner radius. Everybody see it? Now, the outer radius, watch this. You measure from the axis of revolution always. The outer radius, you measure to the furthest function away. Pretty simple. All right, so it would be big R of x is going to be, what's the outer function?
X squared.
X squared. I would have labeled those. Minus the bottom function, 0, which just ends up being x squared. Then little r of x would be from the axis of revolution to the most inside function. So here was the outer radius. From here to here, here's the inner radius. Now we got to find that radii distance. So little r of x. What's the inside function? You're going to go top minus bottom. We're going to take this minus this.
X cubed.
When is it ever going to be not?
It's not in a minute. I'm just doing all simple ones right now. All right, so do we have our outer radius? We have our inner radius. So what we got to do is find the disk of the whole thing completely filled in. Then we got to subtract that disk out and carve out that part that's in white and get rid of it. Okay? So starting with like a big block and then carving out part in the middle. So you can form this conical shaped thing that's kind of hollow. All right, so volume. Here we go. It's the integral from what?
Pi times the integral from
Pi. 0 to 1.
of x squared squared.
All right, so it's going to be outer radius squared.
Minus.
So x squared squared minus.
X cubed squared.
Now, let me go ahead and say what some of you are going to try and do. Some of you are going to say, well, why can't we just go x squared minus x cubed and square the whole thing? That is so different. You got to square each, because what you're doing is you're finding the volume of this disk and then subtracting the volume of that disk. It's really two separate integrals. What you need to understand about properties of integrals is when you add and subtract integrals, it's really separate integrals. That's that property that I erased. I said off that thing you're supposed to memorize for Friday, I marked off that number 29. It's really this, guys. Watch. It's really this integral minus this integral. Let that be x to 6. It's really two separate integrals. You're taking the disk and subtracting the inside disk to get this washer, to form the washer. Okay?
179.
Now, what do you get for the answer?
0.17951.
Point
179.
179? Okay.
182.
Yeah, you only got to go to 3 decimals, and it doesn't matter if you round up or down. All right, any questions there? Feel good about that?
So even on the AP exam, it doesn't matter if you round up or down.
No. Let's do the next one, but let's just do setup, no calculating. Real quick. What does this look like? Let's just do this one together. That's 4 minus x squared over 4. Parabola.
Shift it up 4.
Shift it up 4.
Upside down.
Upside down.
With this.
Well, there's a
It's like
With a
it's shallow.
stretch
It's
or a
shallow.
squeeze or whatever.
yeah, there's a stretch to it. It's actually a shrink. It makes it wider. So it's shifted up 4. 1, 2, 3, 4. And it's opening down and it's really wider, but who gives a rip?
I don't.
Okay? What else do we got?
Y equals 2.
Y equals 2. You guys just tell me. Here it is. There's the region.
It'll be a washout.
It'd be a washer, right?
Yeah.
Now, what'll be
Big
tricky?
hole.
Yeah, definitely got a hole. Tricky part would be finding these two things. How would I find those 2 points? Because I need an.
So the original one equal to 2.
Yeah, you would have to take the original equation and set it equal to 2. You'd have to figure out where this equation, right here, intersects this equation. So you'd have to go 4 minus x squared over 4 equal to 2. I'd clear out. What would you do first?
Subtract.
Sure, you could subtract 4, so you'd have negative x squared over 4. Some people might just multiply everything by 4 first. Equals negative 2. I'd divide the negative out, make it positive. Then you get x squared equals 8. What are you going to get x to be? Plus or minus root 8. Take square to both sides. So one of them would be negative root 8, the other would be positive root 8. You don't need to simplify it to 2 root 2 unless you feel like it. So, and then if I do this real quick, watch how easy it becomes. Okay, outer radius, sweet, that's pretty simple. Inner radius, sweet, knew that, no problem. So then you're thinking, okay, outer radius is what? Somebody give it to me.
4 minus x squared over 4.
4 minus x squared over 4 minus what?
0.
But is the minus 0 necessary?
No.
Nope, so ditch that. And you're thinking, okay, the green, inner radius, 2 minus 0, which is just what?
2.
2. Do we have our outer and inner?
Yeah.
To be volume is pi, definite integral from what?
Negative root 8 to root 8.
Or you could go 0 to root 8 and double again. Outer radius? Minus
4. 2 squared.
2 squared, which is just 4. And then you type it in your calculator or work it out by hand. Is that pretty cool? How do you think you get this?
This is really.
Not bad, is it? All right, now let's make it a little bit harder. Sorry, I erased. I gotta move. Now we're going about the y-axis.
You say we're gonna get through.
What about the y-axis?
No, now we're gonna go about, yep. we're going to rotate around the y-axis now. The directions.
Right on.
The next set of directions say find the volume of the solid. I'll read them. Find the volume of the solid generated by revolving the region about the y-axis bounded by the graphs of the equations. So what I would do is right off the bat is go ahead and graph it the way you're used to graphing it. And then we'll do some switching. All right, number 7. Now keep in mind, what are we wanting to revolve it around now?
The y-axis.
All right, listen carefully. Revolve around y-axis. Everything now has to be in terms of x. Now everything has to be in terms of x. That's different. That means all your equations have to be solved. Sorry, no, I screwed that up. Everything has to be in terms of y. Sorry. Everything has to be in terms of y now. So like everything we've been doing has been in terms of x. We go along the x-axis. We have our limits of integration along the x-axis. All of our equations are in terms of x. Now everything's got to be in terms of y. So all our equations have to be in terms of y, and then our limits of integration have to be along the y-axis. So that means I got to take all my equations and solve them for x. So I can get the equations in terms of y. Now, I wouldn't do it yet. Go ahead and graph it the way. How many of you are better graphing when it's set equal to y? I am too. So let's graph it right now. What is this? Simple. It's parabola. What's y equals 4? Horizontal line. X equals 0. Let's ditch that one. We don't need that one. I don't even know I put it there. I have to rework this notes. At least I know that now. Let's ditch that one. Okay, so what's the region bounded by the two curves? That bowl-shaped, right? Actually, you don't even need both parts because when you rotate it, it's going to catch it anyways. So we're going to rotate that around. Okay? Alrighty. Let's do this. You ready? Now, if I'm going to do this, I got to think about this differently because what's my axis of revolution now? The y-axis. The y-axis is the axis of revolution. So here's my radius. My radius, and I could measure to the right or to the left. It doesn't really matter. Now, because is the radius the same on either side? Yeah. Okay. So you got that. Now it needs to be r of y. That's where it gets a little weird because now it's going to be in terms of y. So the outside function. Here's the problem. The equations need to be set equal to x. This one doesn't have an x, so you can't do anything to that one. But this one, you got to solve for x. So let's come down here. If we got y equals x squared, how can I solve that one for x? Square root of both sides. So you get x is equal to plus or minus what? What is really backed it up? Root y. Is everybody okay with that?
Yeah.
Now, here's the deal. Which piece did I decide to use? The one to the right or to the left?
Right.
Which one's that? The plus piece or the minus piece?
Plus.
So we're going to go, when we do it, it was usually top minus bottom. What are we going to do now to measure the radius? So it'd be square root of y minus what? 0. Because this is the 0. The y-axis is x equals 0. So our radius is square root of y. Still with me? Do we have a radius?
Yeah.
We do. Now we can go ahead and plug it in. Is this a disc or a washer?
Yes.
It completely touches the axis of revolution. Remember, we're evolving around this now.
So their note would be
So be volume is equal to, ready? What's out front?
times 0 to 4.
So be pi. Get your pi out front first.
Definitely going to go from 0 to 4.
Alright, now it's along the y-axis. You're not going along the x anymore. You're around a vertical axis revolution. Everything's got to be in terms of y, including your limits of integration. So we got to go from 0 to 4. I think that's pretty easy to see that's 4. And then it's your radius what? So it's going to be the square root of y squared dy, and then we won't do the integration right now. No, I just want to practice setting these up. Okay? don't you try the next one on your own? Try the next one on your own. Try example 8. Oops. Wrong way. Try example 8. Now I'd graph it before you solve for x, because I think it's way harder to look at. I'm gonna try and speed my board up a little bit here. I got way too many things running in the background. All right. What is this? It's a dome again. What's the radius of the semicircle? It's just the square root of 16. Do we need the x equals 0 here? Probably not. I mean, we're rotating it around that, so I don't need that. I think that's why I put that in there. I don't know what I was doing. Okay, you don't need the x equals 0. It'll be right on the exam. You don't have to worry about them screwing up. For some reason, I put the x equals 0 because I put what you're rotating it around. All right, so it's going to be right 4, up 4, and left 4. And it's a dome. So there's the region. How do I know this is a dome? This is a common graph you're supposed to memorize. All right. Aliens you won't use, but you'll use the dome or this one.
What was the point of even learning alien if we've never used it?
I don't know. I just felt like it.
Just thought you'd throw that in.
Throw it in there. Because I want you to see the difference if you have these switched. If it's x squared minus 16, it's not the semicircle.
It's aliens.
Yeah, it is. All right, so we got the semicircle, we got the region. Now, a lot of people would jump the gun and be like, oh, sweet, disk, and it's around the x-axis. But we're not rotating around the x-axis. What are we rotating around? The y-axis. So we got to change everything.
Yeah.
So it's going to be 0 to 4 either way. And the volume's going to get the same answer either way. But we're practicing doing it along, rotating it around the y. So my radius is here. Got it?
Yeah.
That ends up being, okay, it's going to be r of y. Well, that ding, 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 ding. I need to resolve this. What do I got to solve it for? X. So we got y equals the square root of 16 minus x squared. How do I solve that?
Square both sides.
Square both sides. You're going to get y squared is equal to 16 minus x squared.
Square root everything.
Not yet.
Minus 16.
So you're going to have
Minus 16.
y squared minus 16 equals negative x squared.
Take out the negative.
Divide by negative, so we're going to get negative y squared plus 16 equals x squared. What do we got?
Root them.
Root it. X equals plus or minus the square root of, I'm going to go 16 minus y squared. I just like the positive piece first.
I just switch it.
Okay? Now, which piece do I want to use if I decided to go with this side of it?
Positive.
The positive piece. So I'm going to go right minus left. The right function is the positive 16 minus y squared. And then we're just subtracting 0, which the subtracting 0 matter. I can write it, but I don't really need it. I just need to reinforce that because in just a second we're going to try and do one before we go. Here in a second, the next one. Do we got my radius? So now we just go to the volume formula. What do we put out front?
Pi.
What's the limits of integration?
Definitely
0 to 4.
0 to 4.
16 minus y squared.
Everything's in terms of y. And then you would just evaluate it. Now, if you're doing this by hand, it's great. If you're doing it by hand, this is actually really easy because when you square the square root, what happens to it?
Gets rid of it.
And then it's easy, simple power rule. All right, let's skip down. Skip down to some ones we've done in terms of y. So let's go down to, I believe it's example,
Donut with 20 y.
let's go down to number 12. Number 12, the directions say, I believe the directions read,
Y-axis.
it says, find the volumes of the solid generated by revolving the region bounded by the graphs of the equations about the indicated lines. All right, example 12, they have 4.
The y-axis.
We're not going to do the x-axis. We're not going to do the y-axis. Those are too easy. We're going to go straight to the hard ones. Y equals 8, and x equals 2.
That doesn't say y-axis, it says y-axis.
I know. You got lots of typos. Like I said, I made this for the first time last time. You get to help me fix it all.
This just says different.
So I go back and be able to fix it now. All right, so example 12, this is what we got. All right, let's go ahead and sketch it. What's y equals 2x squared? Parabola with a steeper slope, so it's a skinnier parabola. But I'm not too worried about that. Now, what else do they got for boundaries? I've graphed my parabola. We're after, what's the first step always? Find the what? You gotta find the region. You gotta find the shaded region. You have to find the area first. If you can't find the area, you can't do a volume. Okay? So we got that. What else do we got? We got x equals 2 and y equals 0. So we got the x-axis and the vertical line x equals 2. So we got the x-axis, okay, starting to narrow it down a little bit. And then we got x equals 2. Sweet. Does everybody see the region? It's that triangular shape. Remember, it's the graph, it's the x-axis, and then it's x equals 2. So it's this stuff. Wow. Shade it in. Now, part C. What do they want you to revolve it around? All right, they want us to revolve it around this. And then the next one, we'll revolve it around x equals 2. So we're going to revolve around y equals 8 first. Well, y equals 8 is way up here. Let's see where it is. Let's see what this point is real quick. Let's just check, because maybe it just happens. I don't know where y equals 8 intersects this. If I plug 2 into this, what do you get?
8.
Oh, sweet. So our line, our horizontal line.
Miracle. What are the chances?
The odds of that.
No kidding.
What are the chances?
Wonder if I did that on purpose.
Sweet.
So y equals 8 's right there. Love it. So that's the 0.28. I probably planned that. Okay, now, there's our axis of revolution. Is there a gap at all?
No.
Yeah.
Yeah.
For sure.
A big one.
There's a lot of gap here.
Oh.
He was
Going
just
from
thinking
here to
about
here.
it. Not like that.
It's just
All right.
something to come and get.
There is definitely a gap. When I rotate this region from here to here, you got all this gapped out.
Yeah, you do.
I feel like you planned it.
All right, now, I'm going to rotate it around y equals 8. Now, since it's a washer and not a disc, there are 2 radii. There's an outer radius and inner radius. Draw the 2 vertical strips real quick. So you go from, where do you measure from always?
Right to left.
That's where
Right
it
to
goes.
zero. Right
Not
to
the
the
bottom.
axis.
Where do you measure
Axis.
from? Thank you, the axis. Axis of revolution. So I'm going to go from the axis to the function furthest away. The boundary furthest away.
So that's the top.
That's, hold on, we'll get to that in a second. Now the inner radius would be from the axis to the most inside function. Now notice that's always changing, that's why we have equations. Because this radius is always changing based on this function. This radius actually is going to be pretty static. Or it is static because this function's a horizontal line, that's a horizontal line. 2 horizontal lines are always parallel, they're never going to change. All right, let's do outer radius first. Outer radius. How do you do it? How do you subtract? Always. Now that's about this time the axis is on top. Before it was the axis.
No,
was
no,
always-
We're kidding.
No, 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 no.
0 minus
Top.
X.
It's 8
We're kitty wampus.
minus. You're subtracting these 2 things. This right here, which is y equals 8,
2x.
from this right here, which is what?
2x squared.
No, you're
Eight.
killing this one. 0. Thank you. So what does it end up being?
8.
8. Okay, no 2x squared yet.
I'm at
Alright, there's the outer radius. Now, this,
Oh,
by the way, look at this,
I
guys.
see.
The outer radius is always what?
8.
8.
Oh,
Okay?
Yeah, now it's-
So basically what we're getting, listen, what we're getting is this whole thing. We're getting a hockey puck. But then we're carving out the white out of the hockey puck.
We're gonna get upside down.
You know what we're getting?
Giddy.
You know what we're getting?
And upside
I
down.
don't know what we're getting.
Glass.
You get, it's always top minus bottom. You're getting, listen, you're getting a doggy dish.
Or an upside down cup.
Sure.
With a concave.
I don't think
No.
so. Nordic.
Yeah.
No, it's not gonna be an upside down cup because it's carved out sloped.
That's what I said with concave.
You know what it looks like? One of those skate parks.
A concave up cup. Glass.
Skate bowls that people go,
Like this.
skateboarding
and
in.
the inside goes like this.
Anyways.
Yes, it is.
What is the inner radius?
Yes.
What's this one, guys? That
Yes, it
one's
is.
gonna be, watch, 8
Yes, it is.
minus 2x squared. So we got our outer radius is 8. We got our inner radius is this one. Now, it's going to be bounded from here to here. So it's going to be from this value to this value that we're doing the volume, and we're rotating it around the line, y equals 8. We're rotating it around this. This is what we're going around. That's what I think some of you got. Okay, so volume. What do we put out front first? Pi. Times the definite integral from what? 0 to what? 2, thank you. We're along the x-axis this time.
8 squared.
8 squared, outer radius squared, minus
Inner radius squared.
8 minus 2x squared, squared, dx.
So when the axis is above,
You always go top minus bottom. It doesn't matter where the axis is. Sometimes the axis is below, so it's
why
the bottom.
did
I thought
you
we
do
were around the
8
y
minus
axis.
0 instead
Yeah.
of 0 minus 8? For the radius.
Or y, I thought we were around y equals 8.
Why what? Because top minus bottom.
I thought we were revolving length.
I always do top minus
I
bottom.
thought
Now
you-
here's
I
the
thought that
thing.
was-
I haven't told you.
I thought that that was just like the function or
Aren't we going
No.
around the y?
Now,
I don't know why or the X.
we're going around the line. We're
Y
going
equals 8.
around, listen, we're going around the horizontal axis. It's like going around the x-axis. I'm not going around a vertical axis. The next one, x equals 2, I'm going to go around this, and I'm going to be rotating it this way. Right now, I'm rotating it this way. It's like rotating it around the x-axis. Y equals 8 is a horizontal axis of revolution, just like the x-axis is a horizontal axis of revolution. So whenever you have y equations, it's everything in terms of x. When I have x equations, then it's going to be everything's in terms of y. Okay? And that would be a disk. If you go around if you go around x equals 2, that one's going to be a disk. And your radius is going to end up being this. And it'd be right minus left. Now, one thing I forgot to tell you. You know how I'm saying top minus bottom and right minus left? Can somebody argue why it really doesn't matter? You could go bottom minus top.
because you're going around in a circle.
That's not why, but that
You're
works.
going around in a circle.
That's not why, but that works. Mathematically, why does it work? Why does it not matter?
That's what Griffin said. You're
You're
squaring it so
squaring
it's
it.
going to be positive.
When you square it, no matter what.
Griffin
That's
does.
exactly-
That's exactly what Griffin said.
Oh, did you say that?
He said, "Because you're squaring it."
Yeah.
He said,
Oh, I didn't hear you at all. Okay, so Griffin got it.
No, I said because you square, and then you're like, no.
I was listening to him say a circle or something like that. I kept hearing, all I was hearing was Mark. Okay? The reason why it doesn't matter is because if you go top minus bottom or bottom minus top, if it's negative or positive, you always end up going what? Griffin said you end up squaring it. But the way I teach it so you don't get confused is top minus bottom, right minus left, because when you don't do volumes and they're just asking area between the two curves, you have to do top minus bottom and right minus left. And so I don't want you to screw it up when you do areas. Volumes will always end up being positive because you square it, but in areas it doesn't. So you have to do top minus bottom.
Ow.
Very good. We'll finish this up tomorrow.
I can't stop.
So, will we know today in practice if this week tomorrow?
Yeah, I haven't heard anything